Hi, welcome back to the discussion session 10.4, which is the algebra of matrices. So we'll dive in and do a couple of these and just kind of go through them together. But let's start with number 3. 3 says, is the following matrix operation possible? And it gives us two matrices. And 2, 3, 4, 5, and 6, negative 5. And 2, 3, 5, 3, 5, negative 1. Okay. So the question is, can we even do it, right? It's not even asking us to do it yet. Can we do it? So this is a 3 by 2. And this is a 2 by 3, right? And really what I want is these two inners, right? We always list this rows by column. There's 3 rows, there's 2 columns, so this is a 3 by 2. Here, there's 2 rows, 3 columns, so it's a 2 by 3. And when you write it this way, right, row by column, the number of columns in your first one simply has to match up with the number of rows in the second one. If these match, then yes, it can be done. Right? So, as far as number 3, the answer is yes, yes, it can be done. And then, of course, what is this multiplication? Well, in order to multiply this, I like to think of it as I'm going to cut the first one into rows and the second one into columns, right? And then we just multiply this row to this column, and then to this column, and then to this column, and then the next row to each column, and then the next row to each column, doing the matrix multiplication, which is then just to simply multiply each element and then add the two together. So I would start with 2 times 2, which is 4, 3 times 3 is 9, and add those together. 13. And that'll be, in my new matrix, the first row times the first column gives me the first row, first column. The first row times the second column gives me the first row, second column, so that's here. 2 times 3 is 6, 5 times 3 is 15, add the two together, we get 21. Right? 2 times 5 is 10, minus 3 is 7. And I'm done with my top row, and I'm done with the top row in my solution. So I move down, second row, first column, second column, third column will give me the second row, first, second, third column. 8 and 15 gives me 23. 4 times 3 is 12, plus 25 is 37. 5 times 4 is 20, minus 5 is 15. And then I come down to my bottom one, 6 times 2 is 12, minus 15 is negative 3. 6 times 3 is 18, minus 25 is negative, I just had it, 7. And 30 plus 5 more is 35, right? And I know it didn't ask us to actually go through and do the multiplication, but there it is, that is the multiplication. All right, let's look at number 6. It says for the matrices A and B, it gives us A is 2, 3, negative 1, 5. B is 4, negative 1, negative 2, 1. Okay. It asks us two things. It wants us to find A multiplied by B, and then it wants us to find B multiplied by A, and this typically is the first time in most people's mathematical dealings where something multiplied one way does not come out to be the same thing as multiplying it the other way, right? This is the first algebraic construct that is not commutative. Right? That might be a lie, but it's the first time most people realize it, perhaps. But a times b is taking 2, 3, -1, 5, and multiplying it by 4, -1, -2, 1. Again, the one on the left, I cut into rows. The one on the right, I'll cut into columns and then multiply those. This is a 2 by 2. This is a 2 by 2. These are the same, so this can be done, and my result is going to be a 2 by 2. And so I end up with about the same size. And again, you can think of this guy as, since it's a 2 by 2, it's going to have 4 entries. The top left is the result of the top being multiplied by the left, right? So that is 8 minus 6 is 2. The top right is the result of the top being multiplied by the right, so that's -2, +3, that's a 1. The bottom left is the bottom being multiplied by the left, so that's -4 and -10, that is -14. And then the bottom right is the bottom by the right, so +1, +5 gives me +6. There's my first one, that's a multiplied by b. B multiplied by a, once again, potentially different. Sometimes it's the same. It's not always different, but in general it will be different. But b times a is 4, -1, -2, 1. Being multiplied on the right now by 2, 3, -1, 5. Right? And the reason it's potentially going to be different is now this one that I did have in columns is now rows, this one is now columns, and so I'm doing different multiplication here. 8 plus 1 is 9, and it's already different. Top on the right, 12 minus 5 is 7. -4 and -1 more is -5. And then -6 and 5 is -1. Not only is it different, but every single element is different. It's not even just a rearrangement, it's completely different, right? So, right, that is 10.6. That's number 6, sorry. Let's look at one more, let's look at number 10. In fact, I lied to you, let's not look at 10. I did basically 10 in 3 when it didn't ask me to, so take a look at 10 yourself, work through it, and try to get to it working similarly to how I did number 3. Hopefully this was helpful. I'll see you guys for the next one.